So this is going to be the final clip for this Mustang build. I did get the engine running. I did not get an actual official test drive. I will be releasing a test drive video later on. All I get to in this video is a bunch of little finishing up and tidying up of things. I did have to put a carbon fiber drive shaft in this video though, so you do get to see that. But the rest of it's going to be just finishing up and tidying up the few last tied up ends that I had left over. And the first thing we're going to get started with, as you can see in the image below here, is I was doing the cover. So the cover for the engine had to have a couple of cutouts done in order for it to fit, or I had to remove it. Well, this engine looks a lot better with a cover on it because there's so much stuff in the way as far as like all over the place. It's just a cluster F of an engine bay. So that's why you could see me cutting apart the engine cover to try and make it fit. Ended up looking pretty nice, as you can see here. I got tired of working on the engine bay. I am going to move on to something else. I have in this box something fairly special. It is a carbon fiber drive shaft. So as you can imagine, a carbon fiber drive shaft adds a considerable amount of weight reduction. It also is a little bit stronger. It takes a lot more before these things will fail. We'll say fail for now, because there are several types of failures. A steel drive shaft will twist, if not just tear and break, and then it could go down into the ground and catapult the car without a drive shaft loop. The aluminum drive shaft can do a similar thing. It'll just look a little bit different in how it does it. But a composite drive shaft, like this carbon fiber one here, not only is it lighter than even the aluminum ones, but it's stronger, it doesn't fatigue as fast, and the best part about it is safety. If one of these were to break, it will splinter into a bunch of little pieces, and if it drops to the ground, what little is left of it, that'll just splinter into a bunch of little pieces, rather than catapulting the car into the air. So, safety-wise, these are awesome, and it also offers a little bit of a performance gain because it gets more power to the wheel. Less is wasted in accelerating the excessive weight of the other two styles of drive shaft. So we're going to go ahead, put this thing in. It's pretty self-explanatory. Just a couple bolts, couple flanges. And I'm noticing something as I'm holding this thing up. I can feel that half is quite heavy. I mean, if I go center on this thing, that CV style joint is much heavier than this U-joint style joint. And just by the feel of it, I can just feel the center of it is way less weight than both the ends. Now, how is it constructed? It has obviously a carbon fiber tube here that is a particular kind of a weave to enhance strength in a tube for twisting rotation. And then, of course, it's bonded to this guy here. This is a aluminum flange that is designed to fit inside the tube fairly tightly, but not so tight that it's expanding it. And then I'm pretty sure they use a very good epoxy-style glue to hold it in place. My guess is that this aluminum flange probably goes down a considerable amount into the drive shaft, like that much or so. But it probably thins out as it goes further in. And that's just to disperse between the glue and the aluminum, the composite material, disperse the weight across it evenly without adding too much material and weight to the whole center length of this thing. Now, installing this thing is fairly straightforward. A few bolts, couple flanges, but the CV joint style flange, it does have this style of eyelet unit, and that has to be put on there. It's kind of like a washer weight spreader kind of a thing. And then, of course, there's two different length bolts here. It's just going to be bolted up and forget about it, basically. I am going to put a little bit of Loctite on the threads of the bolts because the last thing I need is one of those walking out and destroying a rather expensive drive shaft for the guy unnecessarily. Now, if he breaks it from actually getting traction or something, that's another story. That's on him. But I need to make sure I do my part and I don't break it for him by not correctly tightening things and not correctly putting Loctite on there to prevent it from having an issue. Putting it up there, I'm just going to start with one bolt for each side. I'm not going to worry about the flanges or anything. I'm just going to get it up there, put one bolt each side, thread it in partially, just to hold it in place until I can put the other ones in with the Loctite. Well, that most certainly is not going as planned. This differential is going to have to be shifted back a little bit because that's easier than pushing the engine and tranny forward. But basically this flange down here does not have enough movement to get into the spot where it needs to go. So I'm going to take these front bolts, loosen them up enough that I think I can slide the diff back some. And the bushings in the back, I'm not going to be able to loosen those up and do those because it's just going to go against the bushings either way. So loosening them doesn't do me any good. But I think I can pry on this thing, shift it back, shove something in between the differential and the frame, and it will allow me to get that drive shaft up there. But as it sits, the drive shaft isn't quite short enough to get in there, and if it was, the joint would be extended too far anyway, so we can't have that. So, by the design type, there's nothing else I can do. On second thought, I'm just going to do that.
So that pipe that I'm cutting right there, that is actually the AC pipe that I removed from the previous AC system to update it to make this engine work. And all I'm doing is preparing to install the new oil flange. I'm going to make it, cut it, weld it, build it, and get that new oil flange in so I can start the vehicle.
That was a hideous weld. Aki pooey. Well, that aluminum, even though it's a fairly new piece of aluminum, the refrigerant had contaminated it. Caused all kinds of issues right when I got off the bat of welding. Not cool, but whatever. I think I got it to where it welded decent. I had to pile on. I had one spot where it was my fault, where I got it too hot and it moved away over here. But that's okay. So I was actually planning on this part of it anyway, where I'm going to hit it with my sander. I have a flat surface area on my sander, and I was planning on that anyway, and that's why I welded this side of it, the actual flange side of it, because it'll make the other side look a lot better when I pull this guy out of here. So now there's no weld on this side of it, and I'll have to test this thing to make sure it's sealed, but I think it will be even if I sand it, because I intentionally overheated it a little bit, but I got it too hot by a little bit, if that makes sense. And that's why this part folded away from me, and I had to sit there and build up with the welding rod this area. So I'll just go ahead and I'll sand it down, make it so it's a flat surface again, and then I'll attach it to the car, and it should be perfectly fine. Of course, I got to put a fitting on this end over here once it's cooled off enough that I can hold the thing and everything. So I'm just building a new one because I had originally bought a flange and this threaded doohickey here. So this is for a Dash 10, of course, and there's no way it's going to fit. It's way too close. You do have to have some kind of special fitting that brings it away from the V-band clamp that is right here. This guy is too close to the V-band clamp and won't work. So you have to have something like this. Now, I bought this thinking I may or may not use it. Probably not. But I'll have it for the future if I ever need it for another project. However, I may actually use it on this one if I don't use my weld-on bung that I have. And then, you know what? I'll skip the rest of the process, and I'll just bring you guys back for the finished result and show you what it looks like in the car. I may or may not get rid of this elbow here. I'm going to do some test fitting before I mount the actual and fitting part of it. But I know I need the bend that goes outward. So I may be able to just put the and fitting right here. We'll see. I got to see how the compressor housing and everything fits. So we're going to see how this thing fits. This is, just to give you an idea here, this is the one that came with the On3 kit. Now, it is like an aluminum solder technique. I believe that's used to hold it on there. It might be some kind of strange epoxy. I believe that's the aluminum solder that a couple of companies make. This stuff works okay. I mean, it's perfectly fine. But I wouldn't want to try and tweak this thing to make it so it fits. So if I were to try to put this in there, it ends up hitting the exhaust, where the wastegate pipe comes out, unless I take the turbo and I tip it crooked. Well, I want this feed tube for the oil to go down straight so it hits the bearing perfectly. I don't want anything crooked or unlevel when it comes to the feed tube for the turbo. I don't want this guy to experience any smoke coming out the tailpipe, anything like that, if they got some kind of weird thing going on with the turbo. So to minimize that, I'm going to make sure that stays straight. So I don't want to use this tube because it hits that. I'd have to tilt it. So here's how that one sits, right? Kind of give you an idea here. This is the guy that I made. So if I put it up next to it at the same angle, you can see it comes out completely different. So it actually goes outward more, whereas this one comes this way more. And I did that because that way it avoids that pipe and it still clears the clamp that is in there. Now the tube that I'm using is a little bit thicker tube, it appears. Not by much, but it is a little bit thicker. And then I did end up using the fitting that I had purchased. I just cut it off and then took the lathe and machined it to fit this pipe. And then took and welded this guy. And that welded a lot smoother on that round. I'm not sure why. This guy here, you can see I got it nice and flat. And it looks a lot better. And I did leak check it. So in order to leak check it, I took some Dawn dish soap and just smeared it up in here really good. And then took my air nozzle and pressurized it with the rubber tip up against this area and went all the way around a couple of times to see if any bubbles popped up anywhere. Nothing pops up, so I feel comfortable that this thing does not leak. And furthermore, it's not under pressure anyway, so it's really not as critical that it doesn't leak, because once the gasket is on here, I did have the pipe all the way up. So the gasket should seal on the pipe theoretically, not just the housing, as long as the gasket hole is smaller. I'll find out in a little bit. But another thing you'll notice, the flange thickness. Look at how much heavier and better that flange is than the cheap one that they send with their kit. Which, I mean, it's fine as long as it seals. It's not under pressure again. But it is nice to have a nice heavy flange there. So, a little bit of an improvement. And it's definitely at a lot better angle. So, I'm going to go ahead and get that guy in there. And then what I need to do with this pipe is cut it down and then make it so it's bent at the correct angle to actually hit this thing so I can attach this flare nut to that pipe. So I'm going to get that in place, get the compressor wheel in place, and then I'm going to work on the PCV hose here. They did not include any kind of PCV correction system with this particular kit. I'm sure they probably offer some kind of catch can system, but I don't have it in here. So I'm going to recommend that the customer gets a catch can and hooks the hoses up the exact same way that I do this. Now, when I talk to On3, they say they typically take the ball out of here and then vent out of this side and that side, and they just vent it out. I don't personally recommend that. I like having an actual crankcase system because otherwise, especially with E85, you end up with a lot of moisture buildup in the engine oil, and that's obviously no good. Then you have to change your oil more often, and it just becomes more of a problem. This guy's going to be daily driving this thing quite a bit as far as just cruising around it. He's going to be putting a lot of miles on it. So where he goes to toy around with this thing is probably 60 miles, 50 or 60 miles from where he actually lives. So he's going to drive it to this place, play with the car, go race a bunch of people, and then have to drive it back. So it needs to be reliable, and it needs to be able to put on some miles without him having to change the oil every 1,000 miles. That would be retarded just because of moisture buildup. So I have a hose coming off of the large PCV pipe that is in that valve cover on this side that I also use to pressurize so I could drill the holes for the drain for the turbo, right? So when I was pressurizing that, I was also checking the airflow. So once I got the holes drilled for the turbo drain down here, I left both fittings off while that little blower that I have was blowing into the crankcase. It had a lot of flow coming out. So I know for a fact that that valve cover does flow a considerable amount of air, and it should be able to evacuate for the ring gap that he has and the power that he's making on this motor. Now, if he planned on making 12 to 1,500 wheel horse, something like that, he's probably going to need to increase the airflow for the PCV system a little bit. He'd probably have to add another port inside the valve cover for some kind of draw part to create a small draw through to filter out the air and whatnot. But he would have to take this guy off, which is the original draw pull area, and turn that into a vent instead because it is fairly good sized. So a couple of things he'd have to do. Now, theoretically, there's a check ball in here. I am going to verify it before I'm finished here. I'm going to pop this guy off and then pull the little PCV valve off because I want to verify that the check ball does work properly, that if I try and blow backwards through it, it does not allow air to go into the motor. So I'll pop this guy off here, do that as well, just as an extra security measure, because the last thing I need is when this intake is under boost for it to be pushing air into here. If that's the case, I'm going to have to put a check ball in here if it doesn't do it automatically. So another thing that I figured I'd note. Aside from that, when you guys return, I'm going to skip the exhaust. I've done enough exhaust on this channel. When you guys return, this thing will be running. I may not even have the exhaust on it for the first fire up, and then we will go ahead and go for a drive once I have the exhaust on here. I did have a little issue with one of the exhaust pipes. I'm going to have to cut and weld and fabricate and mess around because On3's jig that they had I don't think was correct. Maybe I somehow didn't line something up. I highly doubt it though. I'm 95% sure that it has something to do with the jigging system from On3, because even with all the V-band clamps they have in here, I just can't get it to line up no matter how hard I try. So I assume that one pipe has a poor jigging job done. Maybe the jig shifted or something in the middle of welding everything up. I have no idea. But let's go ahead and get to the startup and the full running of the car. The moment of truth is here. I don't have all the parts to complete the front clip and do my air filter thing that I want to do, but I have to try and start this thing so I can move it back and forth easily. I'm going to need to do a couple things in the garage before the parts come in for that, and to push this thing around would be a lot of work. I have the fuel pump hooked up. I believe I am ready to start it. I did prime the pump a couple of times just to try and check for leaks. I had one leak down here, and then there's another leak over there. I think it's gone now. I just had to snug the fittings up a little bit tighter. So I believe I'm ready to give it a test fire. There's no exhaust. It's not completed. I have it back to where I guess the cats would go. Well, actually, no, the cats sit in the front. I have it right behind the transmission. That's where it's cut off. I'm going to give it a shot. I have no antifreeze in here either because I'm still waiting on fittings for antifreeze. But if I can at least start it, that's all I need to be able to do, because what I need for this thing is to be able to start it and just pull it in the garage. I'm going to push it back. When I go to take it out, I'm going to push it out, push it into my parking spot. But to get up that hill, it would be really nice to be able to start this thing, to be able to pull it back up. So I'm going to do my first test fire here, and then the next round will be with the exhaust on, and we'll go on a test drive. So hopefully, fingers crossed, it goes smooth. This was a lot of work, and I would hate for something to happen now that tells me I screwed up, other than maybe, a sensor unplugged or something, because there is a lot going on in this engine bay. But with that, let's go ahead and start this thing, see what happens. Okay, I don't think it primed long enough. Give it another shot. Well, that's a bummer. It kind of started to ramp for a little bit, and then it gave me a check manual code. So I fear that it's not going to actually stay running. It won't even try and start now. It won't crank it over. So I think the thing has gone into full. I refused to start limp mode. It sounded like it was healthy. It sounded like there was nothing wrong with the motor. So I feel like the motor part is definitely good to go. I mean, I just went through it. So if something was wrong, it would have been seriously wrong already. It could be a high pressure pump type scenario. It could be a number of things. So I'm going to look into it, and I'll be right back. Because I found out after that first attempt that I showed you guys just a moment ago that this car goes into a form of limp mode where it won't let the starter go. Now, you can't just clear the powertrain codes. No, Ford had to make it way too difficult. I did not crank this thing that horribly much, but apparently it was enough for Ford to say, hey, put it in safety. There's something critically wrong. Whatever. Is what it is. I had to clear all the codes and all the modules that had codes to get the thing to crank over again. I need to get a tune in this thing. I don't have the tune from the customer yet. So I have to wait on him now at this point. But at least I got it to fire up. It doesn't appear to be leaking any fuel, and that's a good start. So we will be right back with a tune and a way to make it run, because I believe those big injectors that are in there are too big and it's too rich. I even put E85 in this thing in hopes that would lean it out, and at least it kind of sort of runs now, but still not really. It has a safety on the throttle. It won't let me operate the throttle, so I can't lean it out with the throttle. Nothing I can do except for get the tune in here so that it'll actually function. So we will be right back. Finally, I got a bass tune in it. I'm going to go ahead and do the first start on the bass tune on camera. Let's see how it goes. Still no exhaust. Still not ready to test drive it. But bass tune, nonetheless. The door is ishy-booey. Shut the lights up so all the bugs don't come in. Finally, it stopped running like dog crap, and it actually ran. So I'm gonna get this thing pulled out and get on the test drive as soon as I get the exhaust on a little bit later. Right now I'm not putting the exhaust on. I just need to get it out of my way so I can get some work done tomorrow. So I believe I have the intake scenario figured out. Now, of course, On3 claims that it would fit here. I just don't see it happening, so I have come up with my own solution. This is a 4-inch to 3-inch adapter. Of course, keep in mind the actual impeller size on this thing is smaller than the 3-inch pipe, so I have no concern about airflow necessarily. But being a nice smooth adapter like this and at a 45-degree angle, if you need one of these, let me know. I can probably find them for you. Otherwise, I'll try and remember to put a link in the description below. But these guys here are pretty nice. They convert it, and then it is soft enough that the one area where it does slightly bump into that sensor right there, the AC sensor, I did have to tweak the AC line a little bit. Just got to be cautious not to break it. But it is just barely pushing against that sensor. However, being an intake tube, I don't see it being a problem. So I have one of these on each side of the engine. You can see this one here also looks very similar. Now this one, I have also hooked the Pcv hose up to the pipe down here. You really can't see it because it's black, but it's way down there. In fact, you might be able to see it right there, but I highly doubt it. It's threaded into there. I took and welded one of the Dash 10 bungs into the pipe itself and then sprayed over it so it's black to match the pipe. And then I have that pipe, which has a small bend in it, going down to here. I have another Union rubber hose. I don't like putting a bunch of rubber hoses, but this is what's going to be easiest to take apart later if anybody ever has to. And plus, it's not an actual boost pipe, so I'm not so concerned. Notice I just used the little worm clamps because it really doesn't need much. But I have this pipe, which is another 45, going to this coupler, and then this was supposed to be aluminum. According to the order from Amazon, this is aluminum, but it's actually like a poor grade stainless steel. Whatever. It just means I can't actually weld it onto this pipe for the adapter, which isn't the worst thing in the world, but this is a transition from 4 to 3 inch, and being a nice smooth transition like this, I feel like the airflow will come around the filter nice because the filter has a nice contoured airflow area inside of it, and then this will nicely contour into the smaller pipe, which will create a good velocity feed into it. And now all I have to do is hope that I have enough clearance for the bumper. Now originally I had the filter sitting right up here, but there is a part of the bumper that is in the way. So you can see this part right here, which is like a weird light fixture thing. This is in the way. Now I'm hoping the filter is going to sit down here and still be able to clear just enough room to make it fit. I'm going to try it here in just a second and see what happens, but I sure hope it fits. So the actual plumbing is in the way. You can see this tube going right here, hitting the light that is right there. If I take that plumbing and I move it that direction over to that pocket there, I think I can make it fit. It's going to be interesting, but I'm going to give it a try right there and see what happens. And then on the other side of the car, this one here is super close. Like, I think if I just drop the filter down, I'll probably be able to get it to fit in there. And then this will come up just enough to clear the filter and still allow for the fender liner to go in here. It's going to be a very close fit, but I think if I just drop this down a little bit, it will fit. So first I'm going to try and do that before I even mess with the other side, just because this side looks like it's so close to fitting. So we have a little bit of extra clips for you on this one. I ended up going into detail about my ASE certificates that I received, as seen previously in this video here while I was welding. Now, I talk a little bit about some personal stuff here, so I included it at the end because it's not needed for the Mustang build. But I figure if you've watched the Mustang series this long, you're probably curious about me and may want to know something. I don't know why. Maybe you want to know something about me? Totally your call. Stay tuned if you want to see it. If not, don't watch it. I don't care. Do what you gotta do. Of course, don't forget, if you like this video, like, share, subscribe, and as always, I hope to see you on the next episode. Thanks for watching. If you didn't notice, I am wearing an old shirt. This is actually my shirt. So, I don't know if you guys knew this or not. Little history on me. One of my first jobs that I had was actually at a radiator shop. At this radiator shop here. And I had my ASE certs way back long ago. I didn't renew them. So they're obsolete now because why? I work for myself. The only reason I used my certifications was when I was first getting started in the automotive industry, just so I could get the job. So I had the criteria to say, hey, I can do this job. Why don't you hire me, give me a shot? I got a few jobs, never really needed to re-up my ASE certs because I was proven. I proved to them that I knew what I was doing, and so I never redid them. But I am technically an ex-master auto technician with advanced level test or whatever. So I got all my certs taken care of, but I don't have them anymore because they are out of date. Not that it really matters to me anymore because I work on my own and I really don't give a crap. So I may have to do a re-up on a certain test, but I think it's a state test, not an ASE test. And that's for refrigerant and Freon stuff. Obviously, I do it really janky right now, but I'll probably be getting a license for doing it properly. But I'm going to have to buy a machine. I think I have to have a machine before I can get the license. And I don't know if I want that expense. So we'll see how it goes. I might try and get a license for that, but